All right, today I want you guys to start with a quick warm-up. So go ahead, get your notebooks out, do these two problems. You can pause the video until you're ready to look at them. All right, now that you have these completed, we're going to go through them using the rules we looked at yesterday. The first one, 3x squared all to the second power, that is a power to a power. Remember, as you're looking at that, 3, there is no exponent on that 3, so we can rewrite that as 3 to the first power. It's got that hidden exponent, and x to the second power, all to the second power. So those two things are the same. We're just highlighting that the 3 is to the first power. Now, when we have a power to a power, we have to bring that second power through to both of these. And we do that by multiplying the exponents. So it's 3 to the 1 times 2, and x to the 2 times 2, which ends up giving us 3 squared times x to the fourth power. All right, sorry if that doesn't look that great, but 3 squared times x to the fourth power. You can simplify this further if you really wanted to. 3 squared is 9. We could write that as 9 times x to the fourth power. All right, for the second one, when we're looking at this, remember our rules apply if they are like bases. The only ones that are like bases are the y's. So those are the only ones that we can combine. We have 2y to the third times z to the first times y to the fourth. We need to combine those to simplify them. Because we are multiplying, we are going to add the exponents there. So nothing changes with the 2. There's nothing to combine. There's no other numbers to multiply. We have y to the third and y to the fourth. So add those together. 3 plus 4 gives me 7. 2y to the seventh. And nothing changes with the z to the first power. So we can just leave that as a z. If you wanted to, you could put the 1 as an exponent there, but it's not really necessary. So those are that's your answer right there. All right. Today we are going to add a couple new rules. So as you're going, we are going to look at, we've looked at power to a power. We've looked at multiplying with exponents. Now we are going to look at division with exponents. All right, so in our division, we have the idea that dividing with powers, remember again, this is only with the like bases, we are going to end up subtracting. For an example, if I have x to the 9th power divided by x to the 3rd power, that's the same as we're going to do subtracting. So we have x to the 9 minus 3. All right, and that ends up being 9 minus 3. It gives us x to the 6th power. So division, we are going to subtract. Oh, there should be a t in there. Oh well, you'll get the idea. There. Another way that you could look at that, you can see why this works. If we write out what this is, x to the 9th power, that's the same as x times x times x 4, 5, 6, 7, 8, 9. And if I'm dividing by x to the third, there's 3 x's there. If we look at that, x and x would cancel out. That would cancel out. That would cancel out, become 1. We are left with 6 x's, which gives us x to the 6th. All right, the next rule that we are going to look at is dealing with negative exponents. All right, when we're dealing with negative exponents, to turn a negative exponent to a positive, we're going to pull it across the line and change the sign. Okay, pull it across the line and change the sign. What that's going to look like, if I have x to the negative third over y to the negative second, I am going to pull the x down across the line. All right, pull the x and the exponent. So this whole piece is going to get pulled down and change the sign to a positive, x to the third. For the y, we are going to do a similar idea. We're going to take that y to the negative 1, pull it across the line up, and that will change our sign to a positive. So we are going to write y to the second power. So starting with the negative exponents, we pull them across the line and change the sign. Now it only has positive exponents. These two things are equivalent. So what do you do if there is no line? For example, if we have just x to the negative second power, we can make that into a fraction by putting it over 1. Now we can pull it down across the line. So take that whole piece, bring it down across the line, and change the sign. So now on the bottom, we're going to have x squared. Now we can't just leave the top empty, so we will have a 1 up top. It'll just be that 1 by itself. We can always write something over 1 as a fraction because anything divided by itself is 1, and then that just pulls it down across the fraction bar. All right. And our third rule for today is when we have the 0 power. All right. When we look at something that is to the 0 power, for example, x to the 0 power, that is going to equal 1. 2 to the 0 power is equal to 1. 5 to the 0 power is equal to 1. X squared times y to the third to the 0 power equals 1. Anything to the 0 power is equal to 1. All right, so in general, anything to the 0 power is equal to 1. All right, anything to the 0 power is equal to 1. Now, you will need to put all of these exponent rules kind of together to just work through some of these problems, you might have to use several of the rules at one time. You might have to multiply, you might have to divide, you might have to use the zero power rule, but we can apply all of these rules together to simplify expressions with exponents. Okay, so why this zero power rule works. If we look at something like 2 divided by 2, we know that that is equal to 1. 2 divided by 2 is 1. What we can rewrite, we could also say that 2 to the first power over 2 to the first power is equal to 1. All right, we just use that hidden 1 exponent rule. Now, if we're dividing with like bases, 2 and 2 divided by 2, we can subtract the exponents, 1 minus 1, so that would be 2 to the 1 minus 1 power, and 1 minus 1 is 0, so 2 to the 0 power, and since it still is equal to 1, 2 to the 0 power is 1. Sorry, this is a little sloppy there. Alright, so 2 to the 0 power equals 1, anything to the 0 power is equal to 1. Now when we're going through some of these problems that you're going to work on, you're going to have to apply multiple rules to work through them. I will go through an example here just to give you a way to kind of look through and figure out what rules you're going to need to apply. Okay, I'm going to give you guys an example to work through so you can kind of see how you should approach this, what you should look for. On number 14, if we look at this, if you notice the front numbers 4 and 2, there are no exponents with those. We can treat them just like regular numbers. You guys have been doing that for a long time. 4 divided by 2, we know that is 2. All right, so we can address that. We have 2. Now, we have an a squared on the bottom. We want to get rid of that. We want to take that a squared and we want to pull it, or a to the negative second, and we want to pull it up across the fraction bar. Get rid of that negative exponent. Okay, so that a squared is going to get pulled up above the fraction bar and the exponent becomes positive. So 2a squared. Now these, they're like bases, so we can subtract them. B to the second and over b to the fourth, b to the 2 minus 4. That gives me b to the negative 2. 2 minus 4 is negative 2. Now we want to get rid of all negative exponents, so we got one more thing to do. We're going to take this and we're going to pull that down across the line and make it a positive. So this one is 2a squared over b squared. All right, and now you can work through some of the other examples that you have on the homework page. Make sure you're checking your answers so that you're on the right track.